Hello, this is Semantic Web Technologies, lecture number 3, Semantic Web Basic Architecture 2. Last part, part 6, the limits of RDF and RDFS. So up to now we have learned a lot about knowledge representation, and we have taken into account RDF, where we can formulate or represent knowledge about simple facts, and RDFS, where we can model schemata and we can formulate classes and connections to other classes and restrictions on classes. But the problem is we do not really know if this really is sufficient for a representation of knowledge about the world. What can we represent? What can we not represent? So I will give you a few examples what would be the world with RDFS or without it. So let's look at the following small problem. First of all, here we have some RDF knowledge. We have an animal and we have a property eats, and we have here food, which is the range of this property. So the property eats is formulated or represented with the domain animal and with the range food. And food we have two subclasses, which means vegetables, which is the first subclass, and meat, which is the second subclass. So the problem now is if we have represented our world like this, how can we represent animals like the cow, who only eats vegetables? So how should we formulate that the cow is an animal? If the cow is an animal, then the cow eats food, and the food can be vegetables or meat. I cannot exclude one of them. On the other hand, there are, of course, certain animals that only eat meat. And there, of course, are also animals that eat both, that eat vegetables and meat. So this is pretty difficult to implement. And RDFS itself, if you start with a representation like this, is not able to represent things or knowledge like this. So therefore, we need something of more expressivity, more semantic expressivity. Take another example, just more simple. We have a class of humans, and we say, of course, women are a subclass of human, and also men are a subclass of human. But how can you express the fact that the members of these classes can never be in both classes at the same time, or they should never be, in the usual case, in both classes at the same time, meaning that these two classes are disjunctive. So we do not have the means to express that two given classes are exclusively for their members. They are disjunctive, that you can only be part of one class and not of the other. So this restriction is not possible to formulate within RDF or RDFS. Next example. If we want, or we try to create or to represent classes from basic classes, from class combinations, RDFS has not the possibility to do this. We cannot state the fact that, for example, road users consist of the several members of the following classes, of all motorists, of all motorcyclists, of all pedestrians, and of all cyclists. So class combinations, in some sense, also with more restrictions, are not possible to make with on the basis of RDF or RDFS knowledge and representation language. So this is not sufficient enough. We don't have the necessary expressivity in semantics. Another example, for example, this is pretty simple. We have human, and we say human always have parents. But usually we know every human has regularly two parents, so a father and a mother. But this knowledge representation has no means to restrict the number of parents to two. So this is not possible. You can define an infinite number of parents for one human. So of course this doesn't make sense. But if we want to formulate or to represent that humans usually always have only two parents, so if we have a number restriction, this is not possible. On the other hand, also restrictions on properties are not possible. For example, think of a transitive property is greater than, if A is greater than B and B is greater than C, then this property should also have the condition, or should hold the condition that A is greater than C, so it should be transitive. On the other hand, you should able to express uniqueness. For example, you only have one mother, so this is a functional property. You must have the possibility to express uniqueness. Or also you can state that two properties might be the inverse of each other. So is parent of is the contrary, then is child of. So each child has a parent, each parent that has a child, they are connected with each other. And this, of course, is an inverse relation, is parent of, is child of. So somehow we must have means to express this fact. So what we need in the end is we need more semantic expressivity. But this is not available in RDF and RDFS. This will be available in the higher levels of this semantic web basic architecture. So we are here in RDF and RDFS, and what we have to look at is we have to look at OWL to create more complex models, and we have to use logic and rules, on the other hand, to express more complicated facts, to express more complicated restrictions. And we will do that in the next lecture. And the next lecture then starts the new part on knowledge representation, where we will deal with ontologies.